Quantum theory has an unsolved problem called the measurement problem. But what if a similar logical contradiction exists inside evolutionary theory itself? And what if both theories are struggling with the exact same question? How does possibility become reality? In this video, we'll explore parallel between quantum physics and evolution and why this may force us to rethink the nature of reality itself. Darwin's theory of evolution was developed long before modern quantum physics. At that time, science was dominated by classical physics, the idea that matter always exists in definite states. But evolution introduced something unusual into this picture, that is, random mutation. Randomness creates uncertainty. Natural selection then chooses one possibility among many. This creates a deep philosophical problem. Classical physics has no room for genuine randomness or real choice. Quantum theory does introduce randomness, but quantum physics itself remains paradoxical. So the question becomes, can evolution really be understood through materialist physics? To understand the problem, we first need to understand quantum mechanics. See, in classical physics, objects always have definite properties. A ball is here at this place, not there. Okay. Measurement simply reveals what already exists. Quantum theory says something radically different. Before measurement, matter does not exist in one definite state. Instead, it exists as a range of possibilities described by something called a wave function. Only when measurement happens does one possibility become actual reality. And here lies the mystery. What causes one possibility to become real? No one truly knows. Quantum physics seems to require two things: a system that exists as possibility, another system that somehow makes a choice. But if everything is just matter, then both systems should behave the same way. So where does the choice come from? That is the quantum measurement problem. So now let's look at this evolution. Evolution also depends on two core ideas. First, random mutation, and second, natural selection. Random mutation creates many possible future biological states. Natural selection chooses which of those states survive. So notice something very remarkable. This structure is almost identical to the quantum measurement. See, in quantum theory, the measured system is possibility. The measuring system is choice. And in evolution, the organism is possibility. The environment is choice. Both theories split reality into two parts. One generates possibility, the other selects among them. And both face the same question: how does choice emerge from matter? Here is the philosophical problem, that materialism tries to explain everything using matter and physical causality, but matter appears unable to fully explain both uncertainty and choice. If causality is purely mechanical, then where does genuine selection come from? And if selection is just another physical process, then it becomes another possibility, not a true choice. That creates a logical contradiction. This is why the argument says, like, evolution, like quantum theory, may be either incomplete or internally inconsistent. This is a profound challenge. Quantum physicists tried to solve this problem using hidden variables. The idea was simple. Maybe randomness is only apparent. Maybe deeper physical causes determine outcomes. But Bell's theorem created a major obstacle. It showed that attempts to explain quantum uncertainty through purely material hidden variables run into serious contradictions. If quantum theory cannot solve this using material causality alone, then can evolutionary theory? That is a challenge posed here. So, what is the alternative? The proposed solution is radical. Reality may not be fundamentally made of material particles. Instead, reality may be understood as a hierarchy of ideas. Ideas naturally contain both uncertainty and choice. Like, take the idea of animal. It contains us uncertainty because it could become a dog, cat, tiger, or elephant. But once refined into dog, a choice has occurred. In this framework, possibility and choice are not opposites. They are two perspectives of the same conceptual reality. This removes the contradiction. So, what have we learned? The claim is not simply that evolution is wrong. The deeper claim is this, that both quantum theory and evolutionary theory confront the same unresolved philosophical problem. How do possibilities become definite realities? If matter alone cannot explain this transition, then our current worldview may be incomplete. Perhaps reality is not fundamentally material. Perhaps matter itself emerges from something deeper, like information or ideas. And if that is true, then the debate is no longer just about evolution or quantum physics. It becomes a question about the very nature of existence.